What's up, guys? We're going to get started with our next section, 12-2. We're going to be covering pyramids this time, so we're going to jump right in. This is the rundown view, so let's get started. So first off, we're going to be dealing with pyramids. Now, the main thing with pyramids is they're just like prisms, but instead they have only one base. So instead of having one base here, it's just one base here, and then everything connects to a singular point. That singular point is called your vertex. It's where all of your lateral edges are going to be meeting. So if we have our vertex, that's this point right up here. Okay, next, we're dealing with altitude. Now, when we're dealing with altitude, it's kind of the same idea as last time. It's what is the height of the entire shape. This time, instead of taking from base to base, we're going to go from base to vertex, and we're going to kind of see what is the perpendicular distance there. Now, what perpendicular distance, again, means is if we look at the base and we're looking at what is the plane there, then if I draw this shape here, there should be a 90-degree angle here. So it's not just anywhere, it's very specifically at this 90-degree angle, which makes this nice triangle, which I'll talk about later. But again, altitude is saying what is the distance from the altitude, or excuse me, from the vertex down to the base. Next, we're dealing with lateral faces and edges. You guys should already know what this is. And then finally, slant height. Now, the slant height, this is going to be the height of your lateral face. I'll be talking about that a little bit more, but basically it's this part right over here. That's going to be your slant height. Now, when we're dealing with this, for the most part, we're dealing with regular pyramids. Now, in irregular pyramids, there's two major things that you need to know. Number one, that your base is regular and your altitude is directly over the center of the base. So if you're looking at your picture over here, this O part, that's going to be the center of your regular base, which I will be talking about a little bit more later. But this is pretty much the major parts that you're going to be working with in a regular pyramid. Next, we're dealing with formulas. When we're dealing with our different formulas, number one, we have our lateral area formula. Now, basically, all the lateral area is doing is just taking all of your lateral faces and adding up the areas. Now, the way we're going to be doing that is we're just going to have the formula. The lateral area is equal to the 1/2 perimeter of the base. This P stands for perimeter of base times L, and L is, again, your slant height over here. So it's perimeter of base times your slant height. Oops. Okay, then after this, we're going to be dealing with volume. Now, again, volume is how much stuff fits inside, and when we're doing volume, volume is going to be 1/3 base times height. So basically, it's really similar to your prism volume, but instead of saying it's base times height, it's 1/3. So a pyramid has 1/3 the volume of a prism. So 1/3 area of base times by height. And again, another word for height is altitude. They're used pretty interchangeably here. Now, when you're dealing with this, you notice you're going to need height and you're going to need slant height. Now, there's two major triangles that you're going to want to break down for most of your problems. The first is going to be your lateral face. So basically what you're going to do is you're going to take this lateral face over here and you're just going to redraw it. Again, I love redrawing. It makes life a little bit easier. So if this was something like 5, 5, this would go right here. 5, 5. If your lateral edge was something like 15, this would go right here, 15. And the nice thing about that is in order to find your slant height now, you have a nice right triangle, you can use Pythagorean theorem. Again, another thing that you could do is instead of giving 15, I could tell you that this angle over here, this is like 40 degrees. And again, this right here would be 40 degrees. And once you have that, again, really nicely, you can use not Pythagorean theorem now, but you can use sine, cosine, tangent in order to find it. So this is really, really helpful if you have your slant height. Next, the second thing that you're probably going to want to break down is your altitude, slant height, apothem triangle. This one's a little bit harder to see, so I'm going to zoom in a little bit, make my pen just a little bit bigger. So from here, that's this triangle here, this nice right triangle here. So the three parts we have again is this is my apothem from O to this part over here. That's your apothem. Next, we have my altitude, that's my height, and then finally my slant height. So sometimes you might need to break down your lateral face in order to get your slant height and use that in order to find your altitude. Again, you can use Pythagorean theorem. Let's say this was something like 7, this was something like 10, then this was x. You could figure out the slant height, but a lot of times they'll give you the slant height and the apothem like 15, 7, and you'll have to figure out what is your altitude. Again, Pythagorean theorem is your friend, and you do have this other option of saying, okay, what is this angle over here? 40 degrees, 12, and then you can figure out x using sine, cosine, tangent. Now, one thing that I didn't cover but you are going to need to know is you are going to need to know how to find the area of a right of a regular polygon. And the way you find an area of a regular polygon is you're going to say 1/2 apothem times perimeter. You're going to break down your little triangle that you've always broken down. If you're having trouble, feel free to watch in the full video. But again, this is just our quick rundown video in order to make sure that you guys can get it really quickly. All right, see you guys later.